Writing a requirements.txt file from scratch for your application can be cumbersome because you need to sort out what packages need to be installed. Worse still, it's tedious to resolve conflicting dependencies, especially for legacy systems. Luckily, pipdeptree can help solve this problem. As the name suggests, pipdeptree is a tool that can display Python packages in the form of a dependency tree. It can help solve the dependency issues and create a clean requirements.txt file for our application. In this post, we will introduce the basic usage of pipdeptree with a simple example. For demonstration purposes, we will create a virtual environment with venv, which is the default tool to manage virtual environments for most legacy systems. Then we will install two packages in the virtual environment. One is Scrapy, a popular web scraping framework which is a typical example here, as it has a very complex dependency tree. The other one is pipdeptree, which is used to inspect dependency trees. If we run pip freeze to check the packages installed in the virtual environment, we will see a very long and very complex list, most of which are the dependencies of the Scrapy library. We can use pipdeptree to print the dependency tree in the current virtual environment. As shown in this picture, Scrapy has a very complex hierarchical dependency tree. We can also use pipdeptree with the -r option to check reverse dependencies, namely to check which packages are dependent on the specified one. For example, we can use this command to check which package is dependent on the twisted package, and it shows that twisted is used by the Scrapy package. As shown previously, pipfreeze gives a very long list of all the packages installed in the virtual environment, which are too verbose to put in the requirements.txt file. Instead, we can use pipdeptree to create a clean requirements.txt file that only includes the top-level packages and not their dependencies. In the previous versions of pipdeptree, we need to use grep to extract the information we need. Now this can be done by setting the depth of the tree to 0 with the -d option, which means only the top-level tree should be printed. This output can then be used to create a clean requirements.txt file with only top-level packages. This is it for this video. Thank you for watching. If you enjoyed the video, please subscribe to my channel for more content.